Hey guys, welcome back again. We're pushing through this. First, I want to apologize that the first day of this week might not have been very clear. Um, I kind of realized this morning, which it's Wednesday morning right now while I record this, that you forgot everything over spring break, like I told you to. And that was unfortunate. But that's okay. We're getting through it. We're going to keep on going here. I'm going to take a step back and we're going to go ahead and look at those transient process and steady state notes again. So I would recommend having those notes out, whether you have them in your notebook or pulling that PowerPoint up again that I put on Canvas for you. So go ahead and have that out. I'm going to have it here and kind of go over it a little bit better again. And then we're also going to go over worksheets 1 and 2, the worksheets that you did on Monday and Wednesday, which I know you really did on Tuesday and Thursday, because it's probably Friday while you're watching this. That's okay. Don't worry about it too much. Okay, first though, you see I've got this circuit set up. I want to go over the circuit that we did before spring break again. So I'm going to go ahead and flip my camera so that you can see that better. Okay, so again, we have these 4 bulbs set up in series with this battery. Okay, it's the same circuit that we see on worksheet 1. Okay, so we have those 4 bulbs in series, and the question from that activity, in case you don't remember it, was how does the pressure in these wires change, right? So we know that this red wire here connected to the negative side of the battery, that pretty much immediately goes to blue because it's connected to that negative side of the battery. And this yellow wire that I'm holding here, which is going to be connected to the positive side of the battery, that one's red. But then we know that this wire here and this wire here are going to change to orange and green, and this one's going to stay yellow through that whole process, right? At the end, we know each of these wires has to be a different color so that the charge can flow at the same rate everywhere in the circuit. But right now, while we look at it, the charge everywhere is, or the pressure is not different everywhere. The charge is not flowing. Actually, the pressure everywhere is the same right now. We could call it, here, I'll disconnect this. We could call it all yellow because there's no charge, everything has the right amount of charge. Nothing has too much charge, nothing has too little charge. When I connect this here, some charge starts to get pulled away, and so now everything's blue. When I connect this one here, this one will turn red. And then, some charge moves around so that what we see is that at first, these first 2 bulbs light, but these ones don't. And then as the time goes on, I'm going to turn my light off and see if that helps a bit. Okay, as the time goes on though, those first 2 bulbs, bulbs 1 and 4, or on worksheet 1, they're listed as A and D. Those bulbs there, they get dimmer while these 2 get brighter. We'll go ahead and watch that again. Okay, so what we see is that bulbs 1 and 4, or A and D, they start out with a high rate of charge flow. And bulbs 2 and 3, they start out with very little charge flow. And then the charge flow here increases, and the charge flow here decreases, and here it increases, until the charge flow everywhere is the same. Okay, I'm going to go ahead and do that circuit one more time. Okay, see, starts bright. These ones get brighter until they're all the same brightness. They all have that same charge flow. Okay, now what I want you to do, if you don't have it out already, is I want you to pull up those notes like I just asked you to a couple minutes ago. Sorry about the brightness in here. Those need to be darker curtains, but they're not. Okay, pull out those transient process notes. That's the online notes from March 16th. So 3.16.2020. It's the PowerPoint from Monday. I've got them right here. Okay, so when I plug this in, things are changing, right? We've got the capacitor there, and so that makes the light's brightness change. That changing is what we call the transient process. But after it goes on for a little while, right? Or if I take the capacitor out, it's what we would call a steady state circuit. A steady state circuit is one where the pressure in each wire is staying the same. It's steady. So the pressure in wire 1 is one pressure, and the pressure in wire 2 is a different pressure. We're not saying that the pressure in all of the wires is the same, because if the pressure in every wire was the same as the pressure in every other wire, then charge would not be flowing. But the pressure in this first wire is not going to change anymore. It's red, it's going to stay red. The pressure in the second wire is orange, it's going to stay orange. The pressure in the third wire is yellow, it'll stay yellow, and so on and so forth. So when we say it's a steady state circuit, we're not saying that everywhere the pressure is the same, we're just saying that it's reached this place where the pressure in one wire isn't going to change again. Okay, that also means that the flow rate into a wire has to be the same as the flow rate out of the wire. Because if the flow rate in and out is the same, then the amount of charge in the wire is staying the same, and therefore the pressure will stay the same. And in order for that to happen, that means that through each wire and through each resistor in a series, the flow rate must be the same everywhere. So in a steady state circuit, the flow rate is the same everywhere because the pressure is not changing anywhere. Okay, the transient process is what we have when the flow rate through each bulb is different. That would mean that the amount of charge that leaves this first wire is different from the amount of charge that goes into the first wire. Okay, that means that if the charge that's coming in is more than the charge that's going out, then the amount of charge in the wire is going to increase, which means that the electric pressure or the voltage in that wire will increase. Hopefully that makes sense. We'll kind of go over it again as we do the first worksheet. Okay, so if the flow rate through each bulb is different, I'm on slide 3 of that PowerPoint just in case you're trying to follow along. If the flow rate through each bulb is different, then if more charge enters through the inflow, then less charge is going out through the outflow, then that's going to make the pressure in that wire increase. Okay, so the change in pressure is caused by an imbalance in the flow rate in and out of the wire. I'll say that one more time. The change in pressure is caused by the imbalance in the flow rate in and out of that wire. So if more charge is coming in and less charge is coming out, the pressure will increase. If less charge is going in and more charge is going out, then the pressure will decrease because the amount of charge in that wire is decreasing. Now, as the pressure in a wire increases, but maybe it doesn't increase in a different wire, or the pressure in each wire is changing, that means that the flow rate through each bulb is going to be changing as well. And as that flow rate changes, it causes the pressure to change a little bit differently, and that basically keeps happening until the pressure difference everywhere is even so that the flow rate can be the same everywhere. Okay, on to slide 4. Again, that process of the pressure changing, which causes the flow rates to change, that is called the transient process. And the transient process continues until the flow rate is the same everywhere and we have a steady state circuit. Okay, so the transient process stops once the flow rate is the same everywhere and we have a steady state circuit. Okay, the very last slide here is just kind of a review of some of that and why we use the capacitor. Okay, so the transient process does occur in every circuit, but it normally happens very, very fast. So in this circuit that I have right here, we see that all those bulbs appear to come on at the same time because it happens very, very fast. Basically, the wire is very, very small. It's big enough that it allows charge to move pretty freely, but it's small enough that just a little tiny bit of extra charge causes that pressure to change. And so it doesn't take very long for the pressure to have changed everywhere to make it a steady state circuit. Basically, it's because the wires have such a small volume, it doesn't take a lot of charge to make the pressure in that wire change. But when we add a capacitor, remember these capacitors have plates inside that are wound up very tightly, so that what we actually have inside of here is a little sheet of foil that's probably bigger than my dinner table, which is pretty big. I mean, you can't really see it. Okay, but it's a very big piece of metal that's inside of here. And there's so much metal in here that it actually does take a while to change the electric pressure. It takes a lot of charge, a lot of extra charge, or a lot of charge taken away to make the pressure in this capacitor different. Okay, unlike the wire, which does not take a lot of pressure or a lot of charge to make the pressure different. This has so much volume, there's so much metal in here that it takes a lot of charge to make the pressure noticeably different. Okay, so in order to reach that steady state, it takes longer to change that pressure so that we can get an even flow rate everywhere in the circuit when we have that capacitor. Okay, I'm going to pull out my handy dandy Crayola markers and we'll go ahead and get started on worksheet 1. This is going to be a little bit of a longer video today than the last few. I do want to say that because I'm putting this on YouTube, I can see how many views it gets and I can see how long you guys actually keep watching the video. Please do watch the whole video, guys, because, you know, we're trying to make sure that you keep learning even though you're not at school. And I know it's hard, but like, I just spent an hour this morning walking around my house wondering how the heck I'm supposed to still teach you when I can't actually see you. So please do come to office hours when you don't understand, and definitely make sure that you watch the whole videos. I'm not going to really make you do a whole lot after this video today. It's mostly just going to be watching the video and then posting a little thing on the discussion board so that I can see that you've at least done something. Okay, here we go. I'm going to close down my computer, and we are going to go for this. Okay. Apparently, it doesn't let me switch views in the middle, so that's a little awkward, but that's okay. We'll make do. Okay. So, color coding and worksheet 1. I'm going to grab a pen, too. Guys, I'm prepared. Yeah, those were my feet. Okay. Great. So, first, it wants us to draw starbursts on the bulbs in the figures that show the brightness of each bulb at the various stages in activity 1. I apologize that I didn't really pay very much attention and realized that you didn't actually do activity 1 recently enough, but now we just did it, so let's go ahead and do it. We're also going to draw arrow tails that show the directions and rates of flow, and we're going to color code our wires to provide a picture of the pressure differences. At the instant that we connect the circuit, we saw that bulb 1 here, or bulb A, lit fairly bright. I'm going to go ahead and give it 4 because, well, I shouldn't actually. I'm going to give it 3. Okay, and this one was the same brightness. We'll call that our standard brightness because I actually used 3 cells. So, yeah. Okay, and these ones were not lit, so I'm not going to put anything there. Since this one is lit our standard brightness, I'm going to put our standard flow over it with 3 arrow tails, and the same here. Now, since there's 3 going through here and 3 going through here, that means that there must also be 3 going through here. But since these 2 bulbs don't light, that means that there must not be any charge flow there. Okay, which I know is kind of weird, but let's go ahead and look at what that must mean for our pressure. If we let the first wire be red, as we should, because it's connected to the positive side of the battery, and the last wire be blue, because it's connected to the negative side of the battery, and we have what we're calling our standard brightness, and this is not, there's no flow here, that means that all of these other wires must be yellow. Oh good, you can see that. Okay, now you might actually remember we did do this on the Friday before we left, or the Thursday, depending on which class you're in. Okay, so you might remember we actually did do that circuit before. Okay, so what we saw at the beginning was that these first 2 bulbs, or the first and the last bulb, they lit bright, but the other 2 bulbs didn't. There was no charge flow because that pressure's the same everywhere there. So at the instant of connection, we saw that the flow rate at point A must have been bigger than the flow rate at point B because that light was lit. So A is greater than B. And the flow rate at point C, well, that was basically none, right? Because we said B is basically 0 and C is basically 0. Okay, so D was actually greater than C as well. Okay, and then A and D seemed to be the same because those bulbs seemed to be the same brightness. Okay, and then the question is, what is going to cause the pressure in the top right wire right here and the bottom right wire to change? And remember what we talked about with the transient process a couple minutes ago was that since there is charge flowing from red to yellow, and there is charge flowing from yellow to blue, but there's not charge flowing in between these wires here that are all yellow, that means that there's charge coming into this wire, but there's not charge going out of that wire. There's charge coming out of this wire, but there's not any charge going into this wire. And so because of that imbalance of charge flow, we're going to have an increase in the pressure in here, or a decrease in the pressure here, and an increase in the pressure here, because there's extra charge coming in here, there's extra charge leaving here. Okay, so what causes this pressure difference, or this pressure to change, is an imbalance in the flow rate. Okay, we have a different flow rate in each wire. And that is what is causing... I'm sorry, guys. I can't apparently hold this and write at the same time. Okay. All right. And then midway through our transient, okay, we've still got blue down here at the bottom, And I'm going to go ahead and I'm going to do this one too. Okay, and at the end, we'll also still have blue at the bottom. Okay, and then we've still got red at the top, because basically the job of the battery, just in case you've forgotten, the job of the battery is to make it so that that pressure difference from the top of the battery to the bottom of the battery is always the same. So those wires will never change from blue and red to a different color. They'll always have to be that color. Okay, the middle wire is actually going to stay yellow in all of these cases, because the amount of charge that goes into that wire is always going to be the same as the amount of charge that comes out of that wire. And the reason is just because of the way that these are evenly spread out, because the battery always keeps that same pressure difference. There's always going to be the same pressure difference from this wire to this wire and from this wire to this wire. So the flow rate in and out of that middle wire will always be the same, which will obviously cause that wire to stay the same pressure. Okay. So then at the end, we know that what we'll work towards with our steady state is for this wire here to be orange and for the wire at the bottom to be green. Because that is what we will need for the pressure difference from wire to wire to be the same for every bulb, right? Red to orange is the same difference as orange to yellow, and yellow to green is the same difference as green to blue. So we know that that's what we're going to be working towards as our steady state. But midway through, that means that we're going to have something between red or something between orange and yellow, right? Because we're increasing this wire up from yellow to orange. So we're going to have something like yellow-orange. And I'm going to do my best to draw that color. I don't think it's going to work very well, but I'm going to try. I don't know. That was okay, I suppose. Okay, and the same here. That means that this one is going to be like yellow-green. Okay, and I'll see if I can do that here. Again, maybe not quite, but hopefully you understand the gist of what I'm trying to say. Okay, let's finish off these questions here then. Okay. So midway through the transient, what happened to the pressure difference across the first and the fourth bulbs? Well, we've gone from red to yellow up to like red down to yellow-orange. So that pressure difference from this wire to this wire across the first bulb has actually decreased, because this pressure has gone up to get closer to the red, right? So that means that the difference in pressure is actually less. What has happened to the flow rates through the first and the fourth bulb? Well, we saw that the brightness decreases here, right? We've got less brightness now. Okay, it's less bright, which means that there must be less flow as well. Okay, these ones have gotten a little bit brighter, which means that there must be some flow here. Okay, so the flow rates through the first and fourth bulbs has decreased. And the pressure difference in the flow rates between these two bulbs, well, that has increased, right? We've seen that those bulbs got brighter. And in our final steady state, okay, we see that the flow rate everywhere is the same, and all the bulbs are the same relatively dim brightness. And essentially the capacitor slowed down that transient so that we could see it. And this is pretty much what the last slide of that PowerPoint that I just showed you was about the transient process. The capacitor slows down the transient process because the capacitor plates have a very large volume. Okay, so the capacitor plates have a very large volume, whereas the wires do not have a very large volume. So it takes a lot more charge in order to compress that charge and increase the pressure in that capacitor plate than it does to do the same thing in the wire. Okay, because I've got a 25-minute video going here, I'm just going to run through worksheet 2 as well. And that's going to make this a little bit longer today, but I think it's been a little bit shorter on the previous couple of days. And I still think that this should take you less than about 45 minutes to get everything submitted on the discussion board. So I'm going to go ahead and run through it. Okay. So here we go. Make sure you've got that. In this circuit below, the positions of the round and long bulb have been reversed from activity 2. I did do that video of activity 2, I suppose yesterday for you. So you should have seen that recently. We saw that the long bulb in the circuit lights, but the round bulb doesn't light. And the reason was essentially that in order for the flow rate to be the same through both bulbs, there has to be a lot more of a pressure difference across the long bulb because it has a higher resistance. So we'll go ahead and we'll color code this circuit. We know that before the final connection, since this wire is connected to blue, it must be blue. But since there's no charge flowing through the long bulb, it must be blue there too. And then everything here must be positive. And since there's nowhere for that charge to go out of the round bulb, then it won't light either because there's nowhere for that charge to get pushed to. Okay, in our final steady state, this one must be red. And again, it must be red because the job of the battery is to make it red. Just like how the job of the battery is to make this one blue. That's always going to be the case because that is the battery's job. And the question is now, what is that middle wire? In order for the flow rates to be the same, that middle wire cannot be yellow. In order for the flow rates to be the same, what we'll see is that the long bulb actually doesn't take as much flow to make it bright. Whereas the round bulb basically won't light because essentially this pressure right here is somewhere in between red and orange. It's a very small pressure difference. Okay, it's a very, very small pressure difference. It's not quite red because it can't be red or it wouldn't flow, but it's also kind of bigger than orange. Okay, so it's basically red, but there does have to be some flow there. So the flow rate here is, it's honestly probably, it's just not enough to make that round bulb light, even though it's enough to make the long bulb light. Okay. We will predict, I'm gonna get that phone to stop. I'm probably gonna trim this out.
Hi, it's Ray, Sandy, and Emily, huh?
Okay, so we did A. B, predict what you would see during the transient phase if we used the large capacitor in parallel with the long bulb before the final connection was made. Okay, so if we had it in parallel with the long bulb, then that would mean it would take longer for this middle wire to go up from blue all the way up to this red-orange. Okay, since that's going to take longer, that means we're going to start still with this long bulb with blue on either side. So it's going to start out not lit, whereas this round bulb would have red to blue on either side, which is obviously a lot. And so that round bulb would start out very bright. So the round bulb would start bright. The round bulb would start out bright, and the long bulb would get brighter and it's going to keep getting brighter until this final pressure difference is reached, at which point the round bulb would go out. Okay, and that is pretty much what we saw happen in activity 2, which you can go back and view that activity if you would like to. Okay, then it says, sketch 3 schematic diagrams with the capacitor in parallel with the long bulb. Color code the wires and show the bulb rays and arrow tails for the following cases. Okay, so let's add our capacitor in here. I guess I should probably use a different color. Okay, so let's add our capacitor in here in parallel with the long bulb. Okay, and so just to further explain what I had just explained up here with B, we're going to see again that the job of the battery is to make that bottom wire blue, always. And we just said that since this wire here starts blue, because of the way it's connected, this one is also going to be blue. Just because of the way that we did that. Oh, I shouldn't have done that. My bad. A little late now, isn't it? Okay, well, that's that. This one is going to be red. Okay, and that one's always going to be red because that's the battery's job. That one's always red. The bottom one's always blue. And what we're doing is we're bringing this one up so that it's close to red but not quite red. So we're bringing this one up so that it's close to red but not quite red. Okay, which means that this one is going up from a low pressure down to all the way up until this round bulb is not lit anymore. So we'll go ahead and do our bulb rays. This one starts out not lit. This one is going to start out pretty bright is my guess. And this one, and it's going to keep getting dimmer. And this one is going to keep getting brighter until this bulb is on and this one is not. All right, this has been those worksheets. Have a good end of the week, guys.